Okay. If you read the numerical and if you see the circuit diagram, can anyone tell me how the load resistances are connected in the circuit diagram? Can anyone try to tell me how the resistances are connected here? Yes, please.
4 ohm and 1 ohm are in series and
Okay.
other are in parallel.
Okay. So I expect that, thank you for your answer. And I expect that everyone should give me that answer in this way. This 4 ohm and this 1 ohm, they are connected in a series. Why? Because in between this 4 and 1, this is a common point, and that common point is not connected to any another branch. So we can easily say that these two resistors are connected in series. So I try to calculate its a resultant resistance. So I can write Rs is equal to 4 plus 1, which is equal to 5. But if you see that in between which 2 points these two resistors are connected in series, if you try to find out, then you will get it. This is a first point where this 4 ohm branch is connected, and this is a second point where the 1 ohm is connected. Means we can say that in between the point A and B, this 4 ohm and 1 ohm is connected in series. It means that when we want to replace this 4 ohm and 1 ohm with the 5 ohm, then I need to connect these 5 ohm resistance in between the point A and B. And then my circuit diagram should be like this. Check it. This is 15. This is 2 ohm. This is 7 ohm. This is 3 ohm. And this is the point A and B. And in between this A and B, this 4 and 1 ohm is connected in a series. So if I want to connect its a resultant resistance, then I have to connect in between these 2 points A and B, and I can connect in this way. This is a 5 ohm resistance. Is it clear? Yes or no? Yes or no?
Yes, sir. Yes, sir.
Okay. Can I draw the same circuit diagram like this? Just check it. Can I draw like that?
Yes.
Get it, my point? It means that this diagram, circuit diagram, I can replace with this one. This is for our simplicity. This is for our understanding. I just replace this diagram because if you see that this 7 ohm and this 3 ohm, this is a common point. Let me consider that this is a common point. Is it right? Here, this branch I just increase, but here no resistance is present. It means that both the diagrams are nothing but same. And now, if you see this simplified diagram, what you say about these 4 resistors? If you see this simplified diagram, what you can say about these 4 resistors, how they are connected?
Parallel.
Parallel.
So I'm always getting very late response. So you should be very alert when I ask the question. Those students know these things. Just give me that response quickly. Now the thing is clear. These resistances are connected in parallel. So definitely we can calculate its total resistance first. Here I can write total resistance, which is equal to 1 upon Rp is equal to 1 upon 2 plus 1 upon 7 plus 1 upon 3 plus 1 by 5. Can you give me that? What is the value of 1 upon Rp here?
One upon 1.176.
I want in terms of fractional part. Give me the answer in this way, 0 point something or 1 point something like that.
0.85.
0.85. Take the reciprocal of it. Rp is equal to 1 divided by answer. Reciprocal.
रेसिप्रोकेट केल्यावर 0.85 आन्सर येतो.
हाँ सर.
Okay, means Rp is equal to 0.85. This is not.
तिथं 1.176.
This is the total resistance. Okay. Now we will apply that to Ohm's law. Apply that to Ohm's law. V is equal to I multiplied by R P here. Is it right? So the total voltage is 15 is equal to I multiplied by total resistance is 0.85. So that I is equal to 15 divided by 0.85. That I is equal to
17.64.
70.64.
Get it? If you have that any doubt, you can raise that doubt. Otherwise, you can note down this answer. And once you return the complete answer, write me the message in the chat box or okay. So now I will take that next example. I think this is over. Now write down the next example, this one. Okay. May I start to solve that example?
Yes, sir.
But can anyone tell me that how the resistances are connected here? Can anyone try?
2 ohm connected in series.
Series.
This 2 ohm and this 2 ohm connected in?
Series.
Okay, next.
Others are connected in parallel.
Oh, no, it's not like that.
All are in parallel.
No, no, it's not like that.
2 ohm and 2 ohm are in parallel.
Which
No,
2
are in
ohm?
series.
Okay,
Series.
okay,
They both are parallel to 4 ohm
okay,
and 2 ohm and this त्याचं
okay,
कॉम्बिनेशन हे सिरीज मध्ये आहे.
okay.
आणि परत मग त्या दोघांचं कॉम्बिनेशन झालं ह्याला पॅरलल मध्ये आणि परत सिरीज मध्ये आहेत.
Absolutely correct. Absolutely correct. Now, I think not all the students will listen very carefully and they will not understand clearly. For them, let me try to explain. See that now you should be at this stage just by observing the circuit diagram, you should get the things clear how the resistances are connected in the circuit diagram. Now I think the one student has explained very nicely how actually the resistance are connected in the series circuit. I want that each and every student should understand with the same way. Because now you know that all the properties of a series and parallel circuit we have solved, I think at least 8 to 9 examples we solved based on it. Now you should be at this stage to understand just by observing the diagram, you can easily tell how the resistances are connected. If not, it means that you are lagging somewhere. It means that the practice, your practice is less. You need to try more. You have to spend the time. Is it right? Now, if you see that, just by observing the diagram, we can easily say that these 2 ohm and these 2 ohm are connected in series. Why? The reason is that in between these two resistors, this is a one common point, and that common point is not connected to any another branch. So that I can write here RS1, which is equal to 2 plus 2, which is equal to 4 ohm. But my question is that where I can connect this 4 ohm in the main circuit diagram. If I want to replace this 2 ohm and this 2 ohm, then how to connect this 4 ohm resistance? For that, answer is you have to check it where actually these two series resistors are connected. It means that in between which 2 points these two resistors are connected in series. So if you try to see in the diagram, this is I say that point A and this is a point B. In between the point A and B, these two and these two is connected in a series. So that it's a resultant resistance of these two and these two is connected in between A and B is there. Means one terminal of this 4 ohm resistor is connected to point A and other terminal is connected to the point B. In this way only you can connect it. Now I can try to draw the remaining circuit diagram by replacing these 2 and 2 in with its resultant resistance. Is it right? So here I say that this is a 9-volt battery. This is 2 ohm. This is 2 ohm. This is 4 ohm. This is 4 ohm. These are the point A. This is the point B. And now we have to connect in between A and B is there. And this is a 4 ohm is there. Either you can connect here or you can connect here or you can connect here. But the thing is, one terminal of this resultant 4 ohm is connected to point A and other terminal must be connected to the point B. Is it that clear? Yes or no? Yes or no?
Yes, sir.
Yes, sir.
Now if you see the diagram, You can easily say about this 4 and this 4, how they are connected?
Parallelly.
They are connected in a parallel, and they are connected in a parallel in between again the point A and B. It means that if I want to calculate its total resistance 1 upon RP1, which is equal to 1 upon 4 plus 1 upon 4. So if you try to calculate, then you will get that answer RP1 is equal to 2 ohm. त्यांचा रिझल्टंट रेजिस्टन्स किती आला पाहिजे? 2 ओहमच आला पाहिजे. आता तुम्ही म्हणताल की सर तुम्ही एवढं फास्ट कसं काय कॅल्क्युलेट केलं? माझ्याकडे एक ट्रिक आहे. कोणती ट्रिक आहे? If the two resistances are connected in a parallel having its equal value, then its total resistance is exactly half of that. Once again, I will repeat. The trick is that if the two resistances are connected in a parallel and having its equal value, then its total resistance is half of the value of that resistance. आता रेजिस्टन्स किती आहे? 4 ohms आहे. त्यामुळे टोटल रेजिस्टन्स तुमचा किती असला पाहिजे? 2 ohms. कॅल्क्युलेट करून बघा. Yes or no?
Yes, sir.
Okay. Now, if I want to replace, आता बघा आपण सर्किट डायग्राम सिम्प्लिफाईड करत चाललोय. आता हे 2 4 ohm पॅरलल ब्रांच मी रिप्लेस करणार आहे आणि त्यांच्या ऐवजी त्यांचा रिझल्टंट रेजिस्टन्स प्लेस करायचा आहे. मग आता रिझल्टंट रेजिस्टन्स नेमका कुठं प्लेस करायचा आणि कसा कनेक्ट करायचा मेन सर्किट डायग्राम मध्ये हे 2 ब्रांचेस काढल्यानंतर? तर आपल्याला माहिती आहे की हे दोन पॅरलल रेजिस्टन्स ए आणि बी या 2 पॉइंट मध्येच कनेक्ट झालेले आहेत. बरोबर आहे. सो व्हेन आय ट्राय टू रिप्लेस these 2 parallel branches, then I have to connect their resultant resistance in between the point A and B, and then my simplified circuit diagram, it should be like this. This is 2 ohm, this is 2 ohm, this is 4 ohm, this is 9 volt, this is point A, this is point B, and I just remove these 2 4 ohm parallel branches from this point A and B, and now I try to put its resultant value, that is nothing but 2 ohm. Is it that clear? Now, if you see the simplified circuit diagram, then you can say that these 2 ohm and these 2 ohm, how they are connected?
Series.
Because this is a common point and this common point is not connected to any another branch. So we say that RS2 is equal to 2 plus 2, it becomes 4 ohm. And now in between, in which 2 points these 2 resistors are connected in series? If you check it, this is a common point. So this 2 ohm is connected to here. I say that point P, and this 2 ohm is connected to here. I say that point Q. In between point P and Q, these 2 ohm are connected in a series. It means that if I want to replace, if I want to remove these 2 and these 2 ohm resistance, and when I want to connect, it's a resultant 4 ohm resistance, so I can connect in between the point P and Q. Means one terminal must be connected to point P and other terminal must be connected to point Q, so that again my simplified circuit diagram must be like this. This is 9 volt, this is 2 ohm, this is point P, this is point Q, this is 4 ohm resistance, and now this 4 ohm resistance I can connect in between these 2 points. Is it that clear? Now this 4 ohm and this 4 ohm, you can easily say that how they are connected?
Parallel.
Parallel. So can I directly write it down here? I can write 1 upon RP2, which is equal to 1 by 4 plus 1 by 4. Again, the case it comes like that, 2 resistances are connected in parallel and having its equal value. So what is the value of RP2? It's exactly half of that. It becomes 2 ohm. It's right. But my question is that in between which 2 points these 2 resistors are connected in parallel? In between the point P and Q. And then our simplified circuit diagram, it should be like this. So this is 2 ohm. This is now point P. This is point Q. And this is 9 volt. And now the resultant value is a 2 ohm. And now you give me that how these 2 and these 2 are connected.
Series.
So I say that R total, now I can write it down, R total, which is equal to 2 plus 2, which is equal to R total is equal to 4 ohm. Get it my point? And once you have that value of R total, apply the Ohm's law and calculate the current. Simple thing is that. Now I don't have the space, but you can try to write it down. So once this numerical is clear to you, please note down this numerical, and along with that, give me that the final value of current I. Just try to find out. Solve these things.
$2.25.
It's a current.
Yes, sir.
So here I can write I becomes 2.25 ampere. All of you please check it.
Yes, sir.
Okay. Whenever you will have that confusion, whenever you will have the doubt, please stop me there and ask the doubt. May I take the next example? So now I think you will get the one thing here. I am going to solve more and more numerical on series and parallel circuit. That my intention is that through every numerical, your concepts about series and parallel will be clear, and I want that you should be very strong in the series and parallel circuit concept. May I take that next example?
Yes, sir.
Okay. It's a bigger one example is there. I will give this example for homework, or better way, try to write down, try to draw the diagram.
सर यामध्ये होल्ट नाही का?
Okay. 9. Here only the terminal A and B is given, but here the question is we have to just calculate the resistance. We don't want to calculate that current here.
Okay, sir.
Read the question.
Okay, sir. Thank you, sir. How far the session is useful. Or
Yes, sir.
okay, can anyone tell me that how one can solve this example? We have to calculate the resistance in between the point A and B.
2 ohm, 2 ohm आणि 2 ohm पॅरलल मध्ये आहेत ना,
Okay,
ते सिरीज मध्ये करायचं. परत 6 ohm आणि 3 ohm पण सिरीज मध्ये करायचं.
हे सिरीज मध्ये करायचं म्हणजे नेमकं कळालं नाही मला.
म्हणजे त्यांची ऍडिशन करायची.
1 मिनिट प्लीज. ते पॅरल मध्ये आहेत, ते त्यांची ऍडिशन कशी करता येईल आपल्याला?
काय म्हणायचं?
हा, काय म्हणायचं ते लक्षात येणं. ओके, that I can tell you. Definitely I will help you. You mean that these 2 ohm, these 2 ohm and these 2 ohm are connected in parallel. So we have to calculate its total resistance. Again,
Yes, sir.
this 6 ohm and this 3 ohm are connected in parallel. We have to calculate its total resistance. Then the total resistance of this parallel combination and the total resistance of this parallel combination is connected in a series. Calculate its total resistance. Then the total resistance of this series combination is in parallel with this 4 ohm resistance. Calculate its total resistance. Then the total resistance, this 2 ohm and this 2 ohm are in series. Again, it's a total resistance, and this 4 ohm is in parallel with the complete total resistance is there. In this way, you can say like that. Get it, my point?
Yes, sir.
Now let me try to solve these things here. So here I consider that these two and these two are connected in parallel. So I say that 1 upon Rp is equal to 1 upon 2 plus 1 upon 2 plus 1 upon 2. So can I say that 1 upon Rp is equal to, here the denominator is same. Only in that case I say that 3 divided by 2, so that Rp is equal to. Yes, please. Take the reciprocal 3, 2 divided by 3, which is equal to 0.667 ohm. Okay. Now, let me take that another one color here. Now, if you see this 6 ohm resistance and this 3 ohm resistance, again they are in parallel. So I can write 1 upon Rp2, which is equal to 1 upon 6 plus 1 upon 3. So 1 upon Rp2 is equal to, can you give me this value?
3/6, 1/2.
1/2.
Or RP2 is equal to 2.
Okay, so
Ye-
you mean that RP2 is equal to
2.
2 ohm. And here what it comes?
0.5.
0.5.
0.5. Okay, no problem. Now see that this 6 ohm and this 3 ohm, they are connected in parallel in between these 2 points. So when we want to replace this 6 and this 3, I can replace in between here. And its resistance is what? It's a 2 ohm. If you see that these two, and these two, they are connected in parallel between the point, the common point here. I say that this is a common point and this is a common point is there. So now my circuit diagram becomes so see that this is 2 ohm, this is 2 ohm, then I say that this is 4 ohm, and once again this is 4 ohm. So this one, it's a total resistance of a 2 ohm resistance, which is nothing but 0.67, and this one is nothing but 6 and 3, which is nothing but 2 ohm is there. Now what about these two resistors?
2.66.
Absolutely correct. So its total resistance is, I say that RS is equal to 2 plus 0.67, which is equal to 2.67 is there. And now this 2.67 and this 4, how they are connected?
Parallel.
They are connected in parallel. So I can write 1 upon RP3, which is equal to 1 upon 2.67 plus 1 upon 4. So I want that value of RP3 directly.
1.6.
1.6 ohm. Is it right? And now, if you see that this is a 2 point, this one is a 2.67, and this is a 4 ohm. They are connected parallel in between these 2 points, so that when I want to simplify the circuit diagram, then I can simplify the diagram like this. This is 2 ohm. This is simplified diagram. This is again 2 ohm. This is point A. This is point B. This is 2 ohm. This is 2 ohm. This is right. And this is the resultant resistance, which is nothing but 1/6. And again, this one is in parallel with this one. That is nothing but 4 ohm. Now, what about these 3 resistors? 2 ohm, 1.6, and then 2. How they are connected? They are connected in series, so that I can write RS1 is equal to 2 plus 1.6 plus 2. It becomes 5.66 ohm. Is it right? And then I say that this 5.6 is the total resistance, okay, of the series combination, which is in parallel with this 4 ohm resistance. So that if I want to calculate the total resistance, so I can write 1 upon R total is equal to 1 upon 5.6 plus 1 upon 4. So that 1 upon R total is equal to
0.42.
Is it R total or 1 upon R total?
1 upon RT.
0.42. And then total R total?
2.336.
All of you, please check the calculation.
2.38.
Okay, 2.3 up to this, it's no problem. Okay, if you have the doubt, you can raise the doubt. Otherwise, note down this example. And let me clear that once again. When you will try to solve the numericals on this point, then and then you will get the confidence. Otherwise not. It means that you have to use your own time to understand the concept through practice only. Once the write-up will be over, give me the message in the chat box. Okay, so I will take that the next example. Hope that everyone have written this example. So write down this example now. Or
Yes, sir.
Okay. Now, please don't write it down anything and just concentrate here because I'm solving this example. It's a little bit different concept is there. Okay. But in that example, the new concept is added, but forget about it. I have yet not discussed about that, the power concept. Okay. So after this example, I will explain within 1 minute what is meant by that power and it's a formula. Okay. So, but at least we can calculate the value of unknown value of a resistance. So what that the numerical is given here from the circuit diagram, calculate the value of R when the total current is of 1.5 ampere. Okay. Okay. Up to this, we can solve this example. Can anyone give me that how this 15 ohm and this 15 ohm are connected?
Parallel.
And how this unknown value of R is connected?
Parallel.
Absolutely correct. But at least we can calculate the total resistance of these two parallel branches, 15 and this 15. We can calculate its total resistance. So I can write here one, or better way. Another one way is that what is this 1.5 ampere? It is the total circuit current. What is this 20 volt? It's a total circuit voltage. If you know that the total voltage, if you know that the total current, can you calculate the total resistance? Yes or no?
Yes. Yes.
How you can calculate it?
Ohm's law.
So I can say that by Ohm's law. If I try to apply that Ohm's law, V is equal to I into R total. So the voltage is 20, which is equal to 1.5 multiplied by R total. So that R total is equal to 20 divided by 1.5. So that R total is equal to
30.33.
13.
Yes, sir.
Yes, sir.
13.33. Is it right?
Yes, sir.
Okay, this is the total resistance. Now, as we know that these 15 and 15 are connected in parallel, so can I write that formula for these two resistance to calculate its equivalent resistance? RP1 is equal to 1 divided by 15 multiplied by 1 divided by 15. So can I directly write it down here? RP1 is equal to 7.5 ohm. Our trick, when the two resistances are connected in parallel and having its equal value, then its total resistance is exactly half of that their resistance is there. So that the 15 ohm is the parallel branch resistance, so that its total resistance is 7.5. Is it that clear? If not, you can calculate it on your calculator and you can check it. Is it that clear?
सर तिथं ऍडिशन पाहिजे मी इंटू लिहिलंय.
It's my mistake. Very good observation, and such types of observation is required for the subject is there. Is it over? Up to this, any point? Any problem?
No, sir.
Okay. Now, let me know that this 7.5 is the total resistance of these two parallel branches, 15 and 15. So that this 7.5 and this R, how they are connected? They are connected in parallel.
Yes.
Is it right? So once again, can I write that equation? 1 upon Rp is equal to 1 upon 7.5 plus 1 upon R. Is it right? So now if I want to do the little bit calculation or little bit simplification, I can try to make the base same, so that I have to multiply R to the numerator and to the denominator here. Also, I have to multiply with the 7.5 to the numerator and the denominator here. so that the base is the same. The base is a 7.5 multiplied by R. So I can write 1 upon RP is equal to 7.5 plus R divided by base is same 7.5 R. So that I can write RP is equal to 7.5 R reciprocal divided by base is 7.5 plus R. Now this RP is the total resistance of this parallel combination. How this RP is connected to this 10 ohm resistance?
Series.
So can I say that here the total resistance, where is that my pointer? 1 minute please. So here I can write the total resistance R total, which is equal to 10 plus RP, so that I can write 10 plus 7.5 R divided by in bracket 7.5 plus R. This is the total resistance of a circuit. And this total resistance must be equal to this one value, because we have already calculated the total resistance. Is it right?
Yes.
So can I equate these two things here, and then I can write 10 plus 7.5 R divided by 7.5 plus R, which is equal to 13.33. Just check it. And we have to calculate that unknown value of R. Here only one R is unknown, so we can easily calculate it. When I transfer this 10 to the right hand side, it should be minus, so it comes 7.5 R divided by in bracket 7.5 plus R, which is equal to 3.33. Now if I transfer this denominator to that side, it should be 7.5 R, which is equal to 3.33 into in a bracket 7.5 plus R. So can you give me that 7.5 R, which is equal to 3.33 multiplied by 7.5?
24.97.
24.75.
24.75 plus
97, sir.
3.97
Hmm.
97 plus 3.33 into R is there. Now this 3.33 R, if I transfer to left hand side, it should be 7.5 R minus 3.33 R, which is equal to 24.97. So 7.5 minus 3.33.
4.17.
4.17. Is it right?
Yes, sir.
Which is equal to 24.97. So that R is equal to 24.97 divided by 4.17. So that unknown value of R is equal to
5.98.
5.98. Can I approximately write it down here? 6 ohm. You can write it down, whatever your answer is there, 5.98 ohm. Just check it. आता या थोडस रायटिंगचं थांबा आणि मी काय सांगतोय त्याच्याकडे लक्ष द्या. आता आपण अननोन व्हॅल्यू आर ची व्हॅल्यू इथं डिटरमाइन केलेली आहे, दॅट इज नथिंग बट 6 ओम. मग ही 6 ओम मिळालेली व्हॅल्यू जर तुम्हाला क्रॉस चेक करायची असेल तर तुम्ही कसं कॅल्क्युलेट करू शकता. आता काय करायचं तुम्ही की इथं आर इज इक्वल टू 6 ओम कन्सिडर करा, बरोबर आहे. मग हा 15, हा 15 आणि हा 6, 15, 15 and 6 are connected in parallel. Calculate its total resistance. Then this 10 ohm is in series. Add in that 10. And once you have the total resistance, once you have the total voltage, calculate the total current and cross check it. If it is 1.5, it means that value of unknown value of R is a 6 ohm is the correct answer. Cross checking. You can do it afterwards. Just this is just for your practice. Okay. But right now you just note down this answer here.